Hello everyone, and welcome to our class video about operations with square roots. Our learning goal is that you will be able to multiply, add, and subtract square roots as well as rationalize the denominator. I'll explain what that means in a second. All of these are skills that are prerequisites of sorts for some of the things we'll be doing later in the unit, so I want you to be familiar with them. Okay, so let's start with multiplication. Okay, so we're going to multiply in these two examples here. Okay, so the way you multiply square root expressions is you multiply the numbers that are outside and you multiply the numbers that are inside. You don't multiply them together, like you don't mix the two. Okay, so in this first example we have 3 square root of 2 times 5 square root of 6. To multiply the numbers outside, I do 3 times 5, which is 15. Then I need to multiply the numbers inside, so 2 times 6 would be 12. That number goes inside. So I have 15 times the square root of 12. You do always need to check, though, whenever you get to this point, can this square root be simplified? Well, in this case, yes it can. I could re-express the square root of 12 as the square root of 4 times 3, finding a perfect square like we did in the last video. 4 is the perfect square, so I'll take the square root of the 4, and that's 2, and multiply it times the 15, which is outside. That would leave me 30 square root of 3. The square root of 3 can't be simplified any farther, so that's my answer. So 3 square root of 2 times 5 square root of 6 is 30 times the square root of 3. Okay, let's look at number 2. This looks simple. Square root of 3 times square root of 3. Well, there are no numbers on the outside. It's just a coefficient of 1. I'll multiply the insides. I get square root of 9. Well, what is the square root of 9? Square root of 9 is just 3. Okay, or you could look at it this way. Square root of 3 times square root of 3, well, anything times itself is squared. So this is the square root of 3 squared. Now, as we said in the last video, the square root and the square are opposites. They're doing the opposite thing. So in this case, they cancel each other out, leaving me only with 3. This would apply to other square roots times itself as well, like square root of 5 times square root of 5 would be 5. And square root of 7 times square root of 7 would be just 7. Multiplying a square root by itself removes the square root from the number. Okay, so that's multiplication. Let's look at addition and subtraction. Alright, so when you're adding and subtracting square roots, you treat the identical square roots as like terms. Okay, remember adding like terms with, say, x's and stuff? So let's look at these couple examples. So in the first one, I've got 2 square root of 3 plus square root of 3. So when you look at that, think of it as like terms. So think 2x plus x. Okay, I'm treating the square root of 3 like an x. Okay, so the coefficient in front of the lone square root of 3 is a 1. So it's like 2x plus 1x. Well, in that case, that would be 3x. So just like that, just like 2x plus 1x gives me 3x, 2 square root of 3 plus 1 square root of 3 gives me 3 square roots of 3. Okay, does that make sense? Let's look at number 4. Now, this says square root of 8 minus square root of 2. I cannot subtract those two because they are not like terms. They are not identical square roots. But, however, I can simplify, and that might allow me to do that. So I can simplify the square root of 8 by changing it into the square root of 4 times 2. 4 is a perfect square. I can take the square root of the 4 and then bring that 2 outside. So I would have now 2 square root of 2 minus the square root of 2. Now we have like terms. So think, this is like 2x minus x. So I'm treating the square root of 2 like an x, like a variable. So 2x minus x is just x. So 2 square root of 2 minus 1 more square root of 2 is just 1 square root of 2. There. So square root of 8 minus square root of 2 is just square root of 2. Isn't that interesting? Okay, let's look at number 5. Those are not like terms, but I could try simplifying them to see if I can do anything with it. So I find a perfect square that goes into each one. For 200, it's 100 times 2. 100 is a perfect square. For square root of 12, 4 is a perfect square, so I can change 12 into 4 times 3. Okay? Take the square root of each one and pull it out front. So I would now have 10 square root of 2 plus 2 square root of 3. Okay? Notice that those two square roots are not identical. So in this case, this is like 10x plus 2y. Those are not like terms. I cannot add 10x plus 2y together and combine them. So this is as simple as it gets. I cannot combine those as like terms, so the simplest way I can write it is 10 square root of 2 plus 2 square root of 3. That's it. Okay, so we've talked about multiplication, addition and subtraction, and our last thing is how to rationalize a denominator. Okay, so what's a denominator? Well, if you remember from some time ago in another math class, the denominator is the bottom of a fraction. Okay, so in math, it's kind of an unwritten rule that no square roots are allowed in the denominator. Whenever you write some expression, you should not have any square roots in the bottom of a fraction. If you do, then the math police are going to come after you. Okay, so, let's look at this example. We have a square root in the denominator. That means the math police are going to come after us. We better change it somehow. Okay, so here's how you get rid of a square root in the denominator. I'm going to multiply both top and bottom by the square root that I find. So because square root of 3 is on the bottom, I'm going to multiply both the top and the bottom of the fraction by the square root of 3. This is the same as multiplying by 1. If I multiply 1 times anything, then I just get the same number. Okay, so that way it'll leave the number the same. Okay, so here we go. So multiplying on top, the 6 is outside and the 3 is inside, so I can't multiply them together. So on top I just have 6 times the square root of 3. On the bottom I have square root of 3 times square root of 3. But remember, we said from before that the square root of any number times itself is just the number inside. It gets rid of the square root. So square root of 3 times square root of 3 is just 3. So I have a 3 on the bottom. Okay, treating this like a fraction, I can reduce it. So 6 over 3 could reduce to 2 over 1. I don't have to write the over 1, so I'll just have it as 2 square root of 3. Okay, so now we have no square root in the denominator. Phew, that was close. We just evaded the police. But whenever you need to, if you have a square root in the denominator, just multiply by that square root on top and bottom to get rid of it. Then the square root will be on top rather than on the bottom. Okay, so hope that all makes sense. So us partners in crime should maybe part ways for now, but we'll rendezvous together tomorrow in class. Alright, see you guys later.